in this question, what you want is to have a rectangle of maximum area to be inscribed in the ellipse with equation x squared plus 4y squared equals 72. And you're supposed to find such a rectangle, area of such a rectangle. So which means you have an ellipse. You'll find that if you try to plot this curve, x squared plus 4y squared 72, it will give you this what we call ellipse. Okay. So this equation will give you the ellipse here, and what you want is to place a rectangle inside, right? So what you want to place a rectangle inside the ellipse. And you'll notice that there's a symmetry. You'll notice there's a symmetry. For ellipse, you have symmetry. So you may use a symmetry to get the answer. So you'll find that it's symmetrical about the y-axis, it's symmetrical about x-axis. So to find the area of a rectangle with maximum area that can be inscribed in the ellipse, then what you can do is you consider just this a point in the first quadrant. So you consider first quadrant. This point xy, and then you'll find that from here to here this length will be x. Then from here this length will be y. And after that you can say this length will be 2x. So it means the rectangle will have length 2x, then we'll have breadth 2y, because this will be also y by symmetry. Okay, and then you can find area of the rectangle. It will be 4xy. So let's look at the solution. So you let xy be the vertex of the rectangle in the first quadrant. And because it's on the curve, because the point xy is on the curve, so we must satisfy the equation of the curve. So which means x squared plus 4y squared is 72, right? So we make y the subject. So that means you can say 4y squared is 72 minus x squared, and y squared is 72 minus x squared over 4. And then you take square root. So if you take square root, it will be square root, then square root of 4, denominator, which is 2. Just as denominator becomes 2. And just as I mentioned, the area is 4xy because the length of the rectangle is 2. So the breadth is also 2. So area is 4xy. And y can be replaced by this square root of 72 minus x squared over 2. So y replaced by this, then 2 and 4 cancel, give us 2, so 2x square root of 72 minus x squared. So this is the area of the rectangle. And what you want is to do differentiation. You want to maximize the area, right? Which means you have to do differentiation. And this is something you should learn. You will find that here it's more difficult to differentiate. Here you have 2x square root of 72 minus x squared. If you try to find dA dx from here, this part you need product rule uv, because 2x is u, then square root of 72 minus x squared is v, and involves square root sign it looks complicated. If you try to differentiate, if you try to find dx of square root of 72 minus x squared, right? If you try to find dx of 72 minus x squared, you'll find that it's complicated. So let's try to find out. If you try to find dx square root of 72 minus x squared is actually 72 minus x squared power half, right? if you try to differentiate this, the answer will be half, and 72 minus x squared power minus half, and minus 2x. And you are using product rule, right? You are using product rule, so you'll find that it is complicated. So later, if you want to, you have to set dA dx to 0. You have to set dA dx to 0. Then you'll find that the equation is not easy to solve. And to overcome this, right, this is something you should learn. You'll find that you consider the square. It means you consider a square. If you consider a square, right, then you'll find that 2x becomes 4x squared. Then the square root sign after squaring, because you square the whole thing, so 2x becomes 4x squared. The square root sign after squaring disappears. Then you'll find that it gives you something easy to handle. So after that, you'll find that if you consider a square, then it's easy to handle. It's easy to handle. So you just call s as a square, and it's just this. So that means you forget the symbol a square. Then you just find ds dx. You can multiply this in. So you'll find that just now if you multiply this in, although you can multiply in by the square root, make it difficult to differentiate, and later difficult to, when you set dA dx to 0, if you set dA dx to 0, it's more difficult to solve. So this one you can multiply the x squared in to give you 472x squared minus x power 4. And then you do the differentiation. Differentiate 72x squared gives you 144x, because differentiate x squared gives you 2x. 2x times 72 gives you 144x. Differentiate x power 4 gives you 4x cubed. So it gives you something simple. And then you just set ds dx to 0. So if you set ds dx to 0, then you'll be just setting this part to 0. You just set this part to 0, which is same as 144x equal to 4x cubed. So it's something easy to solve, right? So it's 144 equal to x cubed equal to 4x cubed, then divided by 4. Divided by 4 is 36. So it's 36x equal to x cubed. And then you can say x cubed minus 36x is 0. You can take out x, and x squared minus 36 is 0. So that means you can further factorize as x minus 6, x plus 6 is 0. So it gives you x is 0, 6 and minus 6. But if you look at what we have, we always say x is in the first, this point is in the first quadrant. So that means x is positive, y is positive. Okay, and the next thing is, you're looking at square root of 72 minus x squared. You're looking at square root, let's use a different color. You're looking at square root of 72 minus x squared. In order to take square root, right? In order to take square root, you need 72 minus x squared to be positive, to take square root. So which means you need x squared to be more than 72. You need x more than square root of 72, which is square root of 36 times 2. Which you break it out is square root of 36 times square root of 2, which is 6 square root of 2. Here should be less than, it means you need x squared less than 72. Here should be less than. So we need 72 minus x squared more than 0. So we need x squared less than 72. So you need x less than square root of 72, which is 6 square root 2. That's how we get this part, x less than square root of 6 times square root 2. So we need x less than square root of 72, which is 6 square root 2. So that's how we have this. So x must be less than 6 square root 2. So it means among the three answers here, after you set dx to 0, you get this equation, which if you solve, you get three answers: x equal to 0, 6, and minus 6. And since x is a point, xy is a point in the first quadrant, x is positive, so it means the answer is 6. And then you just differentiate to show what you want. You're supposed to find maximum area. So that means you want to maximize area. Then to maximize area, because just now we took the square, so it's to maximize s. So that means you differentiate this part. You differentiate this 144x will give you 144. Differentiate 4x cubed, so give you 12x squared. Differentiate x cubed, give you 3x squared, times 4 is 12. Then there's a 4 outside. So we just differentiate to find the second derivative, which is d2s dx squared is 4 bracket 144 minus 12x squared. And then you just sub x as 6. You'll find that it gives you negative 1152 less than 0. So since the second derivative is negative at x equal to 6, you can say x is maximized at x equal to 6. So it's same as the area A is maximum at x equal to 6. And then you'll find the area. Area is 4xy, right? So it's 4x, then just now we work out is this expression. So let's just refer back. Area is actually this expression. Area is just this expression. It's 2x, then 72, square root of 72 minus x squared. So area is given by 2x square root of 72 minus x squared. So we just sub x as 6. So x sub as 6, x squared sub as 6 squared. And if you work it out, it gives you 72 cm squared. So which means if you consider this ellipse, then the maximum, the area or with the rectangle with the maximum area that can fit in is 72 cm squared.